Hello everyone, welcome all. Welcome to Code with the Path, and in this video we will be looking into microservices and its complete architecture. So what is microservices? Microservices is a software development approach where an application is built as a collection of small and independent services. Each service or microservice, focuses on a specific functionality of the application such as handling payments, managing user accounts, or sending notifications. So we need to the services that we make in a Spring application. That is where it comes in the micro services. Each of the services is treated as a microservices. There are various uses of this microservices such as independence. Each service can be independently coded, single responsibility, like each microservice is designed to perform a single functionality which is different from the rest of them. Communication with each other using the protocols like HTTP, REST APIs, and all that. Scalability is there. Each microservice is independent and technology diversity and all. So let's take an example and to understand the microservices in more deep. Imagine a large online store. In a monolithic application, all the features like user authentication, product catalog, shopping cart, and payment processing would be bundled together in one big code base. So, if you wanted to update the payment processing feature, you would have to deploy the entire application, which could be risky and time consuming. But in microservices architecture, these services would be broken down into separate pieces like user service, product service, card service, and order service. Now, each of the services can be handled, developed, tested, and scaled independently. This is the ultimate use of microservices. Okay, so we will be going through more deep into this architecture of microservices, for which a PDF is there. Let's look into it. High level course of microservice architectures. Okay. So microservice core concepts are there. It is a variant of service-oriented architecture, architectural pattern that arranges an application as a collection of loosely coupled. Loosely coupled means whenever we want to make any change in our application, so it is easy to do all that thing. But if the application is not loosely coupled, then it might affect some other areas, and it is not easy to make a change and the entire application needs to be changed. So microservice provides this loosely coupled benefits. Fine-grained services are coded independently and communicating through lightweight protocols such as REST API or HTTP, whatever. Okay. Now, attributes of microservices. Five key attributes are outlined in Martin Fowler's seminal article. So this is componentization via services. Okay, so let's understand it first in easy language. So let me go to here and one component is componentization via services. Okay, so what are componentization via services? So in this, each project should be executed independently. Let me write it out for you. Each project should be executed independently without needing any other project. Okay, so each project can be executed independently. Each service runs and coded individually. Each service or microservice runs and coded individually. So this is it. Okay. And each service can be active at the same time and occupy different ports to run on server. Like, and another one is each service can have different ports to run on. This is basically a overview of componentization where services, where all the services independent, executed independently and can be run on different ports, and also even everything, every service can be deployed in machine, which is outscaling also. Okay, so let me, and also this approach says don't code entire thing in one single project, rather break it into smaller projects so that it is easier to manage and debug code. Okay, so what I'm saying is, open this. Hmm. So let's suppose I'm creating a three microservices here. So one, two, second microservices, and third microservice. These three are basically the microservices. This is service one, service two, and service three. Okay, let me write it. Hmm. Service one, service two, service three. Okay, so these are all the microservices, and each microservices has its own database. See, each microservice has its own database. It is not allowed to interact with each other databases. Okay, so let's do this also. Database. The database of service one is this. Database of service two would be this. Database of service three would be this. Okay, and each microservice occupies can occupy different ports and run at the same time. This is the another thing. Like one is running at 8080, and this is running at 8082, and this service is running at 8083. So this is a pretty much useful feature of microservices. Okay, so this is basically our componentization via services. Like try as much as possible to make your component as services. Modularity is there. The ease of deployment and maintenance comes in this componentization via services. Okay. So the another one is organized around business capabilities. Okay, let's pick it up and okay, okay. Better. So what is there in organized around business capabilities? So uh, in this we need to group the similar functionality together as one service. Okay, so let's write this. Group the similar functionality together as one single service. Okay, if more function of same nature come in future, okay, so if more functions of same nature comes in the future, then you can easily merge it into this service itself. Okay, so we need to group the similar functionality together. This helps to maintaining the application in a better way, and also the developer knows like where to look for if this particular functionality arises. Like if more functions of same nature comes in the future, then you can easily merge it into this service, knowing like where to put this thing and where not to put this thing. Let's understand this with a diagram. Another one. Okay, let's see new. Save it. Save it. Okay. So this another thing it says hmm, similar functionalities should be grouped together. Okay, so okay, so again we are doing this. 1, 2, and 3. These are the three microservices. And the project we are referring to, as you all know, is payment system. Hmm. So this is a payment system. These are three microservices. Let's name these services. Like this is payment validation service. Okay, payment validation service. Payment payment validation service. This is okay. And what service is this? This is our payment processing service. Payment processing services, and this is Stripe provider payment. Stripe provider payment. Okay. So we need to group the similar logic. Whatever logic is there related to validation, we will be putting into this validation service, and whatever logic is there related to the payment processing, like this which is required for processing the payment, we will be doing in this, and whatever logic is required for the Stripe related integration with the application which really talks to Stripe, we are going to put in Stripe provider payment. So these are the separate microservices. One, two, three. Okay. So the next, let's study this. We cannot say let's start with some well boundaries. We make system more modular. The services more independent of other services and ease of maintenance. Right. Okay. Organize services based on the domain, not on size. Like it's the based on domain. What domain is it is of? If we need to group the similar domains, not about the size. Okay, a microservice handles one set of related functions with little or no cross-domain operations. Okay, so in a microservices architecture, a service operates on a well-defined domain. Operations are not defined on data objects or business objects. Instead, it's the domain as a whole, right? Okay, so the next our next point of principles as a microservice principle will be decentralized governance. Now, what is decentralized governance? Okay, let's understand it. Okay, so this is done. I'm just telling you all of the things in brief so that you get a better clarity of these things before going actually to the PDF thing. Okay, so and I'll be sharing this PDF in the bio, so don't worry, you will get it. So first, let's understand the decentralized governance. So, like it means giving when we give the power to the people to decide which technology to use for building the project or service. In this, the tech team got the authority to use like which library, which tools we need to follow. Governance should not be centralized. Like in centralized governance, some restrictions are there. Like only a limited amount of people, limited number of people should be able to give the power and to make the decision. But this principle of microservice says that the power should be given to all the people to use the technology and to provide better ideas. So what we can do, let's do like it includes giving the power to the people to decide which technology to use for building the project or service. Hmm. The technical team got the authority to use and decide which tools or library to follow. Hmm. So this is decentralized government. The governance should not be centralized. It should be decentralized. That means it should be open to all of the people. Okay, so let's read in this. So it lets the teams to use the technology best suited for the services needs. No need of service handling document with slow and incompatible relational database. No more must we use slow and legacy technologies. Then what we really need is a light and fast one. Okay, though, so the progress will be faster if more people they provide their ideas into the business. Teams can use the best tool for the task. Best tools will be used and makes teams satisfied as the results, the other services and the end users of perfect. This is a very much important principle of Microsoft. Now, decentralized data management when possible. Now, using a separate database for each service, this is kind of similar. It makes the service more autonomous and less dependent on any external mechanisms. Decentralized data management. Okay, so let me copy this. Hmm, paste it. Hmm. Okay, let's do it. Okay, so what we can do in this? So every microservice should have a separate database on the whole in this. Okay, so every microservice should have its own separate database. Right. Every service has its own database, helps splitting the system. And other services are not allowed to talk to other databases. If anyone else is supposed to use that database, then makes the another then that service will make the another service API call to processing service, and processing service would write or update the values in the database. Each service should have its own database, like it makes the service more autonomous and less dependent on other of under any other external mechanisms. Okay. It makes the service more dependent, more dependent. Right. Okay. So it's just like each microservice should have its own database. Okay. So hmm, this is the architecture of it. Like each microservice should have its own database. Like this belongs to this, and this. And this is the monolithic database, like the database in which all of the operations are being done in one database, just like this, just like we make here each microservice, and it should have their own databases also, like here and here. These are their databases. And if this service wants to talk to the database of this, then first it can't directly talk to this. So what it will do, it will first talk to this one, and this will talk to its database. Hmm. First, this will talk to this, and this will talk to its database. After getting the value from it, this will again return it to payment validation database. So this is how the flow is made. This is how the flow is being made in this. Okay, so this is monolithic database, and this is microservices. Now, infrastructure automation. Now, without this automation, would result in a system slow and test to deploy. Like there are particular number of steps of infrastructure automation. Like microservices rely on automation for deployment. Okay, so uh, copying it, copy and paste. Okay, so in this microservices. Microservices rely on automation for deployment, like scaling, monitoring, enable deployment, scaling, and monitoring, enabling fast delivery of software, at scale. Like its infrastructure should be automated. Is the main point. The infrastructure should be automated, just like that. Okay. Okay, so without this, automation would result in slow and deployment will be much difficult. Communication pattern leads to truly distributed model. Distribution beyond a single data center is not required. Hmm. It's definitely one of the benefits of this model. Supports highly scalable system and concern every service invocation in microservice architecture is over a remote network call. As such, there is connection setup, tear it down, and while latency on every single call. Okay, so these are just the benefits. Go through it once, and you will get an idea of how it is being done. Hmm. So another important principle of microservices comes here, which is smart endpoints and dump pipes. This is the important one. Okay, so this. Hmm. So what is it like microservices? Micro uh, services communicate to lightweight protocols, HTTP with minimal reliance on complex middlewares. Basically, microservices can't work based upon protocols also. So all communications between individual services in a microservice architecture is over HTTP using the REST-based services. It should be on the REST-based services. So we use async communication instead of sync communication. Okay, so let me write this also. So we use async communication rather than sync communication. Why so? Because sync communication is faster and async model keeps sending the request without even waiting for response. Okay, and while sync sends request and wait for response. So what is the conclusion? Sync basically async model keeps sending the request without even waiting for response. Like it keeps on sending, so it will result in faster development. But sync model sends the request and wait for response. But when it gets response, only then the next request will be generated. So this is the async and sync communication in microservices. Okay, so let's go through it. Microservices communicate via protocols. This with minimal reliance. So this designed philosophically self-contained services that are easy to understand, test, and evolve. Okay, now how do microservices basically based on the REST HTTP? It communicates based on the REST TTP. Like this is one service here, and let me take this. Okay, now this both of them is communicating through what? API. Communicating through APIs, these services. These are communicating through API. So that is what it is. Okay, let's have a deep understanding of this. So all communication between individual services in a microservice architecture is over HTTP using REST-based services. It allows for the use of any coding language or framework that supports RESTful services. These are REST. Teams can develop microservices in any technology, like you can develop it in Java, you can develop it in Python, because it's just a concept, right? You can develop it in any language and in any framework possible. After that, however, cross communication should always be REST, but you can like develop it using any language, but the cross communication should be REST. The protocol standard that it should be following should be REST. They all communicate in common way, despite being developed in any manner. Teamwork faster as they are in the technology they are good at. In pure microservices, any service can talk to any other microservice. Right. Okay. Protocol aware heterogeneous interoperability. Now, services are bound to a protocol HTTP and execute communication over that protocol in a way that works in mixed or heterogeneous environment. Like backend, there is one language and there is another. This is front end, as it is one language. The data science, it is Python. So the issues will be the problems can arise from all of these network calls, as each service can call any service. Any service can call any other service in purest form. There are no constraints on who can call what. These are some of the issues. Another best practice, the API layer. The API layer should not transform the logic. In pure microservices architecture, an API layer is nothing more than an aggregating proxy of all the services offerings. Okay, the API layer is used to stop the outside world or your clients from knowing the structure and organization, or even what exactly service is exposing to a specific function. So when one service try to basically provide something to another service, then API's calls should be made so that only that much data that is relevant to that business should be known, while the rest of the data can be saved. So that's a concept that is being used here. Okay, so shield the outside world. Yes, for your clients, because clients needs more security than all of that. The API layer provides a standardized proxy interface that will expose whatever service endpoints and API operations we configure to expose. The API layer then is pure proxy. Okay, so yes, we are pretty much done with all the principles of microservices. Mhm. Componentization where services, business capabilities, you can go through it. I will provide it in the bio. Decentralized governance is there. Another important principle of decentralized data management. Okay, this point is left, I guess. Products, not projects. Okay, let's copy this. Mhm. Mhm. So, what does it mean? Products, not projects. It basically means microservices are treated as long-term products with ongoing responsibility and ownership. Like this approach here is this approach encourages team to prioritize equality, reliability, and maintainability of project so that there should be any improvement that is to be made in long term. Project should be made in the with a view of long term. Okay, so microservices are treated as long-term products, are treated as long-term products. Okay, while we can think of while building the microservice, think of them as a long-term product. Like what could be beneficial for the upcoming thing that we are going to make it here. You can see long-term product with ongoing ownership and responsibility. This approach encourages team to prioritize quality, reliability, and maintainability. Right. Then the smart endpoints, dump pipes, microservices communicate via this protocols and emphasize self-contained services designed for failure. Okay, so microservice should also be designed for failure also. If there is a failure in microservices, how that should supposed to be handled by itself. So the microservices are designed to handle failure gracefully with mechanisms such as redundancy, circuit breakers, and graceful degradation. This resilience focused approach ensures that the system remains responsive and are available even in the face of unexpected failures. Right. Evolutionary design. In this, a proper design needs to be maintained of a microservices, like how it is being displayed to the end client or end user, iterative based on feedback, changing requirement, and emerging business needs, enabling organization to adapt quickly to market dynamics. So this is it of all microservice architecture. I request you to go through it in order to have a deep understanding and clear understanding of this. And I'll also share this thing with you, but I don't think it's of use because these are just my language. Okay, so that is it in this video. Thank you. Thank you, everyone.